Hello everyone. Okay, so the next concept is hydrograph. Okay, so hydrograph is nothing but basically a graph which shows the variation of discharge versus the given time. So you can see here on x-axis there is time and on y-axis there is discharge. Okay, so the meaning of this hydrograph, it is nothing but it's a graphical representation of the precipitation. Okay, now see here, usually whenever there is a rainfall occurring, so initially it starts slow, then as the rainfall increases, obviously the discharge, the volume of the rainfall also increases. Okay, and then as so it reaches to a point, okay, maximum, and after that it goes on diminishing, it reduces. Okay, and ultimately it reaches to the normal line, it stops. So this is how you represent the rainfall in the form of a graph. So rainfall is nothing but it is proportional to discharge. So as rainfall increases, obviously the discharge in the streams also increases, right? Okay, so you can see this here. So this is called this is the start of the rainfall. Okay, so this is time lag. So time lag means it is the time taken to reach the maximum peak point. That's called as a time lag. And you can see here, this is the maximum point. This is the maximum point. This is called as the peak discharge. It's the highest maximum discharge. And finally, this is called as the base flow, baseline flow. That means this much of water is already available and that keeps flowing. All right. Okay. To understand this more better, okay. So you can see here, it's called as discharge versus time. So it's the rising limb. This is called as the rising limb. Then there is a peak flow. Okay, so the time taken to reach the peak is called as time to peak. Time taken from this point to reach the maximum point. That is called as time to peak. And rising limb is nothing but this is the start of the point. Start, it goes on, it rise, it goes on rising. So that's called as rising limb. This is the maximum peak point. And then this is called as a falling limb. Okay, so falling limb is reduction in the rainfall. That's how reduction in the discharge. And the complete procedure taking place is called as the time of the flood. Okay, all right. So if you have to explain about this, then you have to explain this point one by one. Okay, so they might ask you to explain the hydrograph with its salient points. All right, so you're supposed to draw this. Okay, so this diagram, all right, naming all the points as such, that is A, B, P, C and D, and this is the baseline flow. All right, again the same discharge versus time. All right, so you can notice here, this is called as a peak discharge. Okay, you can see here AB is the rising limb. A to B is called as the rising limb. All right, point P is the peak point, maximum discharge. Then C to D, CD. Okay, here CD is the recession limb. Okay, then TP is the time at peak discharge, time taken. You can see here time taken from the start point to reach the peak discharge. If the rainfall is very fast, it is, if the time taken is faster, and if the rainfall is faster to reach the maximum peak point or maximum discharge, then obviously this TP will be maximum time taken. All right, then TB, you can see here from the start to the end, from point A to B, that is called as TB, that is total time of runoff. All right, next B to C. Okay, this curve BC is called as a crest segment. Crest means that is the point which reaches the maximum. Okay, maximum peak point as such. It reach maximum, again falls back here. So this BC is the crest segment. All right. Okay, so now the components of uh, rainfall is given by, okay, so first thing before we could start this, what is the use of this rainfall hydrograph? So hydrographs are developed basically for a complex storms, so where you don't get the uh, actual data rainfall in the rain gauge station, so that time we use this hydrographs. Okay, and the area under the hydrographs is the total volume of the runoff. So whatever area exists below this here, this is the curve, the area below this curve, complete curve, will give us the area below the complete curve will give the total volume of runoff. Okay, and it also indicates the peak discharge and the time taken to reach the peak discharge, then the base of the flood, everything. So this hydrograph all in all gives the total runoff. It gives us discharge at any given interval of time. Okay, and it gives the maximum peak point as such. Okay, all right. So now the components of this hydrograph are, so this is called as the AB is called as the rising limb. So rising limb, it is nothing but the curve or the line that starts from point A of a rising curve and end at the reflection point B. Okay, so this is the reflection point B, and the shape of the rising limb is influenced by the rainfall characteristics. Okay, so this shape, okay, this is influenced mainly by the rainfall characteristics. Next comes the BC segment. So BC is the crest segment. So first is the rising limb, then the crest segment. So it represents the highest point of the hydrograph. Its duration also depends on the intensity and duration of the rainfall. So that is the crest segment, this portion. Next is the recession limb. So recession limb is CD. So it is the portion of the curve from point C to D where the graph starts to deplete. So this graph starts to deplete with respect to time. So it's also called as the depletion curve or the falling curve. Then the peak time, TP, peak time. It is a time at the peak discharge from the starting point of the hydrograph. So this is the start point of the hydrograph. The starting point, it reaches to the maximum. So that's called as the peak time. Next is the lag time. Okay, so lag time, the time interval from the center of the mass of the rainfall to the center of the mass of the hydrograph, which is known as the lag time. So you can see this is the rainfall, center of the line of the rainfall, mass of the rainfall to the mass of the center of the mass of the hydrograph. This is the time of lag. Mm. Then total time of runoff. Okay, so total time of runoff, it is the total time elapsed between the starting point and ending point of the hydrograph. This is the total time, TB, total time of runoff, that is from A to D. Okay, all right. Next thing is also the same, that is a unit hydrograph. We'll be studying about this again in detail. Now you can see here again it is the same. This is called as the rising limb. This is the recession curve, that is nothing but depletion curve. Then this is the duration. Okay, so the duration of the excess precipitation, whatever is above this is the runoff. Okay, below this is called as the water which flows below the ground and which is stored in the ground. Okay, so this is called as the base flow, and this is the runoff. This is the rising limb, recessive limb, that is recessive curve, and this is called as the base separation line. Okay, whatever flows below is called as the base separation line. Okay, now there are many factors which affects the flood hydrograph. So there could be some climatic factors, there could be some physical factors. So basically main important things are climatic factors and um, physical factors. So climatic factors mainly it is due to the intensity of the rainfall. There is mainly intensity, duration, magnitude on the movement of the storm, and then there will be initial loss due to interception. Okay, and that could be due to evapotranspiration. So evapotranspiration is a combination of evaporation followed by transpiration through the trees. Okay, so if the if you're getting a flood hydrograph which is not a unique, which is not as like this. Okay, so always the hydrograph resembles like this. Rising limb, it reaches maximum and it falls down. So this is a typical hydrograph, but the factors which affect this type of flow, this is a standard unit hydrograph, but there are factors which affect this is so climatic factors, and then there could be any physical factors. So physical factors also include the side shape, nature of the valley, elevation, etc. And there could be some infiltration characteristics that is due to the land use, soil type, geological conditions. And then there could be some channel characteristics and roughness or storage capacity. There could be any such factors. So a flood hydrograph basically is influenced mainly by the climatic factors as well as the physical factors. Okay. All right. That's all for today. Thank you.